Nazim?
Yes, sir. Yes, sir.
Yeah. So I hope we can start it by the time people will join.
Sure, sir.
Yeah.
Okay. So, a very good evening to one and all present for this professional webinar one, which is being conducted by SC3 Committee of Indian Geotechnical Society, which is for the development of the professional forum. So, without wasting much time, I'll introduce to you the session chair for today's session. Am I audible?
Yes, please go ahead.
Yes. Okay. So, without wasting much time, I'll introduce to you the session chair of today's session. It is Dr. A.P. Singh, sir. Dr. A.P. Singh is currently Director of Explore Engineering Consultants Private Limited, Noida. He has done PhD from IIT Delhi, BTech Civil Engineering from NIT Calicut, and ME Geotechnical Engineering from IIT Roorkee with University Medal. Dr. Singh is a Life Fellow of IGS and Life Member of ISR MTT, IRC, ISEG, and member of ISRM and ISSMGE. He is Honorary Secretary of IGS and elected Executive Committee member of IGS National Body, member Board of Studies of Civil Engineering Department of GLA University Mathura, member Managing Committee of World Education Mission WEM Noida, member of Board of Professional Studies of the Department of Civil Engineering, University of Mizoram, nominated member by IGS to BIS for Construction and Related Engineering Services, Sectional Committee SSD 06, National Building Code, Sectional Committee CED 46, nominated member of Technical Committee of ISSMGE for Deep Foundation, that is TC 212, and last but not the least, the editorial board member of Indian Geotechnical Journal. So with this, I welcome you and hand over the session to you, Dr. A.P. Singh, sir.
Thank you, Najim, for introducing me to our beloved fraternity. First of all, I would like to congratulate all the members of SC3 under the leadership of Dr. Jayakumar Shukla for taking this very useful initiative to give an effective wide platform to all the professionals and research fellows. It gives me immense pleasure and pride to introduce today's speaker, Dr. Sivaraman. Dr. Sivaraman is working as Assistant Manager Technology at L&T GeoStructures Private Limited. He obtained his ME in Soil Mechanics and Foundation Engineering from College of Engineering, Gundi, Anna University, Chennai, and PhD from National Institute of Technology, Tiruchirappalli. He has a year of experience in teaching, 5 years of research and consultancy experience, followed by 3 years of industrial experience at L&T. His current assignment at L&T GeoStructure includes planning and implementation of strategic technology initiatives, adoption of advanced and international geotechnical practices, bringing innovations in the construction process of piles, ground improvement solutions, and deep earth retaining systems. One of recent achievements includes effective implementation of CFA, continuous flight auger pile, by completing 140 plus working piles for the first time in India. The CFA working piles were successfully tested and certified for their quality and load capacities. He is also looking after advanced testing of piles and instrumented monitoring of diaphragm walls. He is also a basic certification in dynamic measurement and analysis proficiency test issued by Pile Driving Contractors Association PDCA and Pile Dynamics Inc PTI USA. He has published around 10 technical papers in reputed international and national journal and conferences. He has undergone 6 advanced level geotechnical engineering courses offered by institutes like IIT Bombay, IIT Hyderabad, and NIT Trichy, and participated in 20 plus training programs, seminars, and workshops organized by various institutions in India. He also acted as organizing secretary of 6th Indian Young Geotechnical Engineers Conference 6 IYGC during 2017 at NIT Trichy. He is a member of Indian Geotechnical Society, Deep Foundation Institute DFI, American Society of Civil Engineers ASCE. He acted as Joint Secretary cum Treasurer of IGS Trichy chapter from October 16 to April 23. Presently, he is acting as Executive Committee member of IGS Chennai chapter for the term 23 to 25 and involved as member of BOS and guest lecture for reputed private engineering college under Anna University, Chennai. With this, I would request Dr. Sivaraman, the floor is yours. You please start your lecture. Thank you.
Thank you, sir, for introducing me. And I must thank our IGS President, Secretary, sir, and all the Executive Committee members and TC3 committee members, especially Jaykumar Shukla, sir, for giving me this opportunity to share my experience in this technical forum. I'll just like to share my screen. Okay, I think the screen is visible to everyone.
Yes.
Yeah.
It is visible.
So, good evening to everyone for giving me this and thank you everyone for giving me this opportunity. Today, I'll be discussing about a topic, technology insights for effective geotechnical practices. Initially, this is what I proposed, and then I thought of introducing, my experience in 2-3 technologies, what we have adapted in L&T GeoStructure. Then I thought after that, I prepared for one technology that we have adopted in currently. So I'll comprehensively discuss those that initiative this present meeting. So, good evening and greetings from L&T GeoStructure. We are into piling and underground business. We have marine and intake. We have two segments. One is marine and intake structures and dams and bridges segments. And we have a strategic equipment list, which varies from trench cutters, hydraulic trench cutters, CFA rigs, normal hydraulic rig, reverse circulation drill rigs, and vibro floats for stone columns and vibro columns, and impact hammers for steel pile driving. And we have jack-up platforms for our strategic project applications. So coming to this today's lecture, I'll be sharing my experience in the implementation of advanced technology in geotechnical engineering practice. So first, what is the need for the technology improvement in our today construction scenario is that we need some enhanced performance compared to the present one, and improved safety. That new technology should give us an improved safety parameter or cost saving to our operations. And some cases we need to have to adapt that to make ourselves compatible to the market trend. And second one, to become a competitive edge in the market scenario. And last one, to enhance the client experience and satisfaction. So generally in this technology implementation part, there is a framework which is composed of people, process, and technology. So generally we have to, if we want to scale up our process, we definitely need to introduce some innovative technologies to enhance the process into technology. So if we want to implement a technology or advanced methodology into our regular practice, these are the following process we need to adapt. First one, we have to scan for any ideas or problems which we face during our construction process. Then accordingly, we have to scan and identify several alternatives, and we have to read about each one of them to find the suitable solution that will cater our needs. Third one is that we have to get the approval from our internal and external stakeholders so that we can start incubating our trial process for those implementation prior to the implementation. So once in this incubation period, we have to cover all our shortfalls so that we can go for an effective implementation part. That is the next part. And not only first implementation, then we have to make this a sustainable practice so that it will be carry forward for the future projects also. So coming to the challenges which which we generally used to face during any technology or new technology implementation is that first one is availability or non-availability of regulations or standards. And next one is competency, that what we currently having. And next one is market expectation, present market expectation, and futuristic thinking, and some resistance to the change in the process, and initial investments that also makes some challenges for effective implementation, and the stakeholders by in our customers or any other party who deals with this approval process. And last one is that geological variations that also needs to be considered. Next one, coming to today's agenda, I'll be explaining more into the implementation of continuous flight auger, what we have done in the recent days. So I'll be introducing those CFA technology and application and advantages and specific requirements, ground conditions, design and methodology, references, and case studies. And finally, I'll be covering up what we have actually done, what are the things, what we learned from all this above parameters, and what helped us to implement it in a effective manner. So coming to CFA, most of you know, but I will just briefly introduce it. The CFA is a type of cast-in-situ pile where we will be drilling the hole to the required depth using a continuous auger with hollow stem portion. So at a single stretch, it will go into the required depth. And after reaching the required depth, we will be start pulling up the auger along with the soil. Simultaneously, we will be pumping in the concrete through the hollow stem portion, so that there is no this concrete will fill the borehole portion, and it will make this borehole stable. And also there is no need of providing a temporary liner or bentonite slurry for our operations. And at the end, we have to push the reinforcement cage into the fresh concrete filled in the borehole. So generally, this CFA is applicable from the pile diameter ranges from 450 mm to 1200 mm. And the typical depth, what we adapt for our construction operation is 28 mm, considering the hydraulic rig mast height. And if we want to go for a higher depth, yes, we can do it with crane hung systems. We can go for it. So coming to the application part. So CFA piles can be used for as a load bearing piles below the buildings, and also we can use those CFA operations for preparing primary piles in a primary pile or female pile in a secant pile wall solution, secant pile wall. And third one is rigid columns for ground improvement solutions. Next one is, what is the advantage when we compare to our conventional piling operation, is that higher productivity through faster construction. Because in case of our conventional rotary piling operation, we'll be dealing with soil auger, soil bucket, rock auger, rock bucket. So we'll be dealing with different boring tool, and we'll be boring in multiple stretches. We have to bore and take out the slush out, and there will be multiple operations to in and out of the borehole, and we have to make the borehole stable. So we should not make a chance for borehole collapse or necking operations during trimming concreting solutions. So this is what the advantage for compared to the rotary piling operation. And there is a better quality assurance compared to conventional solution, because we are having an instrumentation monitoring within the cabin. So it will give you all the parameters about the piling and pile built up parameters. Then next one is less ground disturbance. We are not at all using any bentonite or any other slushy or slurry materials for our boring operations, and we can achieve the time saving aspects and cost direct also we can reap, and also indirect cost saving through time saving aspects. So because we are not at all using a temporary casing, stabilizing fluid application, or flushing or borehole cleaning or trimming operations in the piling cases. So what is specifically required to CFA when compared to our conventional solution is that we need a high slump pumpable concrete, because in compared to our normal trimming concrete, here we have to pump the concrete from the through the hollow core pipe in the continuous auger. So we may have to make sure that this concrete is high slump and pumpable, and we may have to ensure the reinforcement cage is stiffer so that we can lift and properly, and we can push the reinforcement cage into the fresh concrete filled in the pile borehole. Next one is we need a stable working platform for the operation of the CFA rig, because while retrieving the continuous auger from the borehole, the sulfate of auger will be there, and then soil which is held in between those augers need those all put together need will have a more number of weight, that all those weight will be acting on the elephant foot below the piling mast. So all this load will be pressure will be transferring through the elephant foot and the below the piling rig mast. So we have to have a stable working platform, and obviously we need some skilled operation team, because this is a new operation procedure this will have. So coming to the ground condition. So these are the favorable ground conditions for the operation of CFA piles. First one is cohesive soil, and second, and granular soil with cohesive fractions. So we can easily punch into those kind of soil, and this kind of cohesive soil or granular soil with cohesive fraction will retain the shape of the borehole, or during the drilling process or retrieval process, those diameter or shape of the borehole will be retained. So that's why it is kept under the favorable conditions. And also higher higher groundwater table is needed, because whatever the concrete we are pumping through the hollow stem during the retrieval process, we are just pumping with high workability concrete. But if the water table is well below the ground level, then the moisture content which is available in the concrete will be sucked out by these surrounding soil. Then it will be difficult for us to push the reinforcement cage after this completion of concrete. So we have to this favorable condition includes the higher groundwater table, so that your moisture content or workability of this fresh concrete is maintained, so it will be easy for us to push the reinforcement cage. Third one is the medium dense to dense silty sand and well-graded sand. So well-graded sand will have some good packing arrangement, so that your wall or borehole wall will be of stable in nature, so we don't have any bulging operation. Obviously necking will not be occurring, because all the soils will be held in between those augers, and while retrieving we are just replacing the borehole empty spaces with high pressure applied concrete. So there is no question of possibilities of necking, but sometimes we'll have this if it is not well graded, then we'll have chances of bulges in the bulges or over consumption of concrete. So, and we can use up to strata of hard or highly weathered rock with uses up to 20 MPa. So general practice is that we will be using this kind of this kind of tool, bottom starter auger with this kind of teeth arrangement in the soft to medium soil, and this kind of hard bullet faced starter auger for our hard soil, dense sands, or highly weathered soil which is uses less than 20 MPa. This is what the starter auger used for various ground condition. Unfavorable case, it is that very soft soil which is having a cohesion less than 15 kPa, because those very soft soils are unstable in nature. Then we'll have more kind of bulging formations will occur at those soils. then your concrete consumption will go high. And loose and uniform graded sands below groundwater table, as I said earlier, your borehole shape will not be maintained as required to us. And geological formations with voids or very soft lenses or water seepage cases, there it will be highly affecting our drilling operation and also concrete pouring operation. And those fresh concrete will be highly affected. Then it will be very difficult for us to push the reinforcement cage into those kind of soil. And also definitely it will be not possible for penetrating into the hard or rock soil below the soft clay, because the ground will be unstable if it is of very soft nature, or bulging or necking formations, soil mining if we are going for poorly or uniformly graded sand, then overconsumption of concrete, as I said. So this is what I said. What is the FHWA guideline? What it specifies is that we should have a minimum spacing of 3 to 5 times the pile diameter for this CFA piling solutions, and auger advancements, that is how much penetration it goes for RPM. So that is what the main factor which deals with effective borehole formation. So if our borehole RPM or penetration rate, if the auger pitch, this is what the pitch, that distance between the two auger blades, typically it will comes around 30 centimeter or 300 mm. This 30 centimeter needs to be penetrated within 2 to 3 revolutions in cohesive soil cases. And for cautionless cases, within 1.5 to 2 revolution, we have to get into this penetration rate, so that our borehole profile is maintained uniform. Otherwise, we'll have kind of screwing effect will be there. Then the soil, whatever surrounding soil will be get loosened, and then these soils will be conveyed to the top of auger. So your borehole profile will be enlarged. So your shape will not be maintained. This is what the main factor that is what specified in the FHWA also. And coming to the Australian standard AS 2159, they are telling that installation sequence should be spaced at 6 to 15 piles diameter adjacent to the piles. Once we cast one pile here, then we have to do another pile with is 6 to 15 piles diameter away, so that the fresh concreted pile will not be affected during the adjacent piling operations. And concrete volume, generally we have to measure with an accuracy of 5%. And main thing is that your concrete consumption, nominal concrete consumption for this CFA pile should not be less than 1 or 5% percentage, because if anything is less than that, it is not unacceptable, because your that is an questionable statement which is there, because there is no chances of there may be, if it is less than that, there may be chances of something went wrong into the borehole. Next one is regarding this design consideration. So in both the Australian standards doesn't tell anything about the design aspects. Only it says that we can do the board cast in situ pile by the option of continuous flight auger system. And one more BS code is there that also gives a provision within their existing BCS pile code that we can go with a continuous flight auger system for casting the pile. But FHWA will give you a comprehensive report, including the design aspect for our case. And FHWA 1999 method is recommended through FHWA document that is based on O'Neill and Rees 1999. So those formulas and design guidelines are there in the FHWA. You can go through it, but I will just highlight what are the key parameters that is covered in this FHWA manual. Is that the alpha parameter in case of cohesive soil, that alpha adhesion value here it ranges from for CFA pile, which is recommended in the FHWA method, is that your alpha value should will be varying from 0.55 to 0.45, with respect to your shear strength of the clay. Whereas in this range is given in IS code for CU of 80 to 100, but in our IS case we'll have range from 1 also, 1 to 0.3 alpha varies, but here it varies only within this confined 0.55 to 0.45. So that will what it conveys is that when the cohesion or shear strength of clay is greater than your 100 kPa, then you will get an what is it, higher CU value, I mean alpha value, that is 0.45, which is greater than your conventional IS method. So you will get better skin friction compared to our conventional BCS pile. So if in case your pile toe is resting on a clay, then what they are suggesting is that 1 times diameter depth from the bottom should be neglected. That skin friction in the bottom 1D should be neglected. This is because when compared to your basic, I mean, conventional BCS pile, you will have a borehole cleaning arrangement. So we'll have cleaned bottom borehole will be there. But in case of CFA, we don't have this kind of flat or uniform pile base, because bottom you will have this auger teeth arrangement, then you'll have concrete pump arrangement. So that's why the bottom 1D is neglected for our skin friction consideration. And if your pile top, pile top is with clay, which is having shrinkage suspected to shrink, then we have to neglect those layers which is in contact with the atmosphere, or wherever there is a change in seasonal change in groundwater table, those layer we have to neglect those skin friction values. And coming to the end bearing, we have to go consider the soil properties, which is 2 times diameter of the pile below the pile toe. This is what the value we have to consider. And NC here suggested is 6.5 to 9. So coming to cohesionless soil, so we'll be using SPT N60 value for our design, and here lateral air pressure coefficient L depends upon a beta parameter, that will vary from 0.25 to 1.2. So we'll get in the top few portions, not in the bottom portions. And end bearing here in the CFA case, as I said, there is a difference between the pile toe formation in conventional BCS and CFA. So we'll have restricted end bearing value of 4.3 MPa. So verticality or tolerance compared suggested in Australian code AS2159 is that your deviation should be less than 1 in 100th of that is 1% of complete pile length. And in IS case, with normal BCS conventional case, we'll have 1.5%. And in case of batter pile, if you are going for a batter CFA pile, then this angle of inclination should be restricted to 6 degrees. It is 84 from the horizontal, that is 6 from the vertical. So maximum batter angle is restricted to 6 degrees in case of CFA piles. And we definitely need instrumented monitor data for our CFA pile application. Here is that typical instrumented data which we observe we'll get it after this piling operation. So this last 3, this will give you the introduction about the details about the CFA pile, what we are drilling date, pile concrete diameter, length, everything. So what is the consumption, our consumption of concrete, everything. Then here this graph will show last 4 parameter will show the drilling aspects like penetration rate, drilling speed, pressure at the bottom, and first parameters will give the parameters while taking out the auger. There is concreting pressure, concrete pumping speed, and how the pile buildup has happened it will calculate within the instrument itself. So that will clearly give you the pile profile, auger depth, auger rotation, everything, all these aspects. So this is what suggested for CFA. So we need to have this kind of dedicated instrumentation arrangement for CFA. And coming to the references, we have code aspects, we have British codes, BSc Geotechnical works, board piles. So they have a class which permits to execute this board piles using continuous flight auger system. And also same for our Australian code, they're having a specific class that allows them to execute through continuous flight auger system. But there is no Indian code as of now. Then now we have a committee formed by the CED 43 Soils and Foundation Committee. Panel 20 was composed in which L&T GeoStructure is also part of that committee. So we have given our inputs for the draft code for CFA in India based on the DFI of India's initiative, which is taken in the 2019 and their documents. So coming to the technical document references, as I said, the FHWA manual, and then followed three documents are out of DFA of India's initiative, which took place in 2019. So these are some case study references from international scenarios. You can see these case studies are for application of CFA for foundation piles. You can see this pile diameter changes from 630,000 mm, and pile depth they have executed of 28, 22, 21 meters, and productivity, so 14 to 19 piles per shift. You can see the piles can be executed within 30 to 40 minutes, depends upon cases. And they have gone with clay, silty sand, and SPT N value more than 45 also. These are several other references where they have used this CFA for various applications like sewage treatment plant or foundation piles for CFA. For various purpose like buildings, sewage treatment plant, residential building, industrial buildings, office buildings, and everything. So you can see what we have to take it out that we can use this kind of CFA files wherever we have more number of piles, and the diameters is of 600 to 1200. We can go for this, and the time is around 30 minutes to 40 minutes, as I said earlier. Then we'll have a good productivity compared to our BCS operation. Generally for BCS will be need 3 to 6 hours per pile for this kind of 600 mm diameter piles minutes. So these are other references, international references. They have used this CFA as a retaining wall, that is secant pile wall solutions 880, and again generally will have this 880 secant pile walls, and they have already used for in various locations in Italy. And so coming to Indian trials, what happened in previous years, last decades. So L&T Larsen & Toubro has made an initiative under Dr. K.S. Ramakrishna during 2010. They have made a trial of 6 numbers of CFA pile 600 mm diameter to a depth of 18 meters at Rajpura thermal power plant. So there is a silty clay and sand soil, and they have achieved productivity of 60 minutes per pile. So this is what case study in India, where they made the trial at India, and followed by DFI of India's initiative in 2019, where L&T made the sponsorship, and a design mix was done by our L&T research and testing center at Chennai. Those representatives were there as a part of this initiative for mixed design arriving process. So this happened in Haryana. So pile diameter is 611 meters depth. So they have casted 6 numbers of pile. They were tested for vertical, lateral, and uplift capacity, including 2 numbers of piles, and they have achieved a productivity of 40 minutes per pile. So coming to this main part is that implementation by L&T GeoStructure. What I was a part of this initiative for the past 2 years because I was taking care of this technology initiatives in L&T GeoStructure. So what is the roadmap? How we have achieved this one? This great achievement is that initially we have formed a technology task force. Generally, we'll have 2-3 initiatives, out of which the CFA is one of it kind into this. So we have developed some roadmaps to how stage by stage roadmaps how to effectively implement all these technology initiatives. Then we have gone for several round of discussion with experts and original equipment manufacturers. Then we thought of using our existing rigs so that we can remove those conventional Kelly bars and we can put this kind of continuous auger, so that we have purchased only the auger systems, and we have modified our existing rigs, piling rigs, and we made our first trial at our Numaligarh refinery piling job. We already have a piling job site at Numaligarh refinery, Assam, Golaghat district, Assam. And we done this in front of our clients to showcase them this CFA technology. Followed by, we have done several trial piles, and we have established the methodology, and we have made test piles and initial pile load test and everything, so that will give confidence to the client and all the stakeholders involved. And followed by after that, we have got approval for executing those remaining piles using the CFA methodology. We must thank our clients. Coming to the implementation part in India. So these are the key factors that were taken into our to-do list, or I could say like key parameters that needs to be addressed while we are using, implementing CFA in India. So we have several differences between implementing CFA in abroad and in India. So generally, we'll have one of this is, so we'll have full length rebar cage for our piles, but in foreign practices, they will have they won't have full length rebar for piles, so we'll have partial rebar cages, so it will be easy for them to execute. And the cutoff level of piles will be generally in will be at the ground level, so it will be easy for them. And but in case of our Indian cases, our cutoff level of pile is below the ground level, then there that issues needs to be addressed while we are implementing in India. So first one is site feasibility. We have to check whether the soil which is available at the site is feasible for CFA or not. Then those diameter and length is within our doable limit or not. Then what is the rig capacity, auger tool, other plant and machinery is what we have to arrange it for CFA. And main important thing is concrete for CFA and reinforcement cages. And definitely we have to go for initial load test for ensuring the or assuring the quality and load test capacity of the CFA to the clients. So this stage, so we have identified our job site or implementation site as Numaligarh refinery expansion project. Where we are, as I said already, we are doing the pile. Conventional BCS pile in several packages in those expansion projects. So our location is at MSB, ETP, and HGU locations within the NRL refinery campus, Assam. And the clients were Numaligarh Refinery Limited and Mathesh Energies Private Limited, USA. And our project management consultants were Technip Energies and Tyson Group Solution. So those were supportive for us in this initiative. So coming to the rig aspect. So as I said earlier, we have several our conventional hydraulic piling rigs, out of which we have assessed all our equipments, and we have identified rigs which are capable to execute CFA pile, or we can convert or modify those piling rigs into CFA operations. So we identified one of our equipment, that is Casagrande B300 machine. So basically we have an requirement that as much as possible we need to do the length of pile. So we gone with 28.5 meter requirement. So as per our conditional assessment of existing piling rig, so we chosen this B300 machine. And initially, the piles operating at normal hydrocarbon projects or this refinery expansion project or industrial expansion projects will have a piles of 500, 600, 750, 900, 1000. So this is what the range will be having for requirement for our market requirement for our piling, standalone piling jobs. So initially we thought of purchasing 600 and 750 diameter CFA auger set. So main thing is that we need to have this kind of auger set, and we need some cleaning arrangement, auger cleaning or store auger arrangement, so that while lifting, this mechanical arrangement will help us to clean the auger, so that those soil which is held between the auger will not spill down while going in the height higher elevations. So here itself, we have to remove all these sludges, so that we want to remove manual operation. So this mechanical arrangement needs to be there for our operations. Then we'll have this bottom hole arrangement for concrete, pumping the concrete. So your concrete will be pumped from the concrete pump, and this concrete will flow through these pipes, and it will be fed from the top pass through the hollow stem portion, and it will be delivered in the bottom. So we'll have a plastic or a steel kind of um, uh, plastic cap here, so that it will be removed. I mean, we have, after going to the required depth, reaching the required depth, we will start pumping the concrete with higher pressure, so that this cap will detach from this bottom, and then will concrete will start pouring from the bottom. Then we can start lifting the machine. Second one, tool, as I said, so we have to decide which diameter we need. So as we have number of piles in the diameters of 600 and 750 in that particular site, so we purchased two diameters for our operation. So based on our requirement of 28.5, we have purchased in sets of so 4 numbers of 6 meters, like that. We have to if our requirement is for 15 meters length, then we can reduce the number of sets we can remove and plug. It's like plug and play arrangement for arrangements in the rig. So we can remove and replace whatever the diameter of continuous auger tool, and can remove and add required numbers of length of augers. We had to ensure that all these augers having joints having the proper torque capacity. Main thing, as I said, the instrumentation is mandatory for our CFA piling operation. So we need to have instrumentation fitted with the piling rig. So we have purchased Genload's instrumentation. Though we have a pressure gauge fixed in the gooseneck at the top, that will measure the concrete pressure, which is pumped through this hollow stem portion, and we have this pressure gauges fitted with this all these mechanical components, so that it will give how much torque is there, torque and RPM. All these things will be measured, and also hydraulic pump pressure, and one antenna based solution for this stroke pump. Concrete pump strokes are up and its operations. So all these things will be integrated to a monitoring device, which is available at the operator's cabin. So coming to the other P&M deployment is that other than this piling rig, we need to have concrete pump. We have to decide what is the diameter of pile and what is the length of pile. Accordingly, we have to select the concrete pump, because there is a difference in using the concrete pumps with respect to diameter and length. Because if your length is 28 meters, for example, and you have a diameter of 0.6, then we have to take the base of auger retrieval rate of 2 meters per minute. Sorry, 2 meters per second. So that accordingly, this concrete should be pumped through this hollow stem and the borehole. So we have to calculate the volume of the borehole, volume inside the pipe. So pipe, for example, your pipe length is 28 meters. Then your concrete passage length, if you consider this 28 meters up, then 28 meters down, and few 20 to 30 meters from this base of the rig to your concrete pump. All this length needs to be considered while deciding upon the concrete pump. And you need an excavator, so that we can remove this slush then and there, and transit mixers to the required capacity. And the main thing is that we can only crane is needed only for lifting a single stage, lifting the reinforcement cage at a single stage. So in international cases, they are going with segmental reinforcement caging by having a overlapping with U-clamp arrangement. But in this case, there is an issue with getting permission for a segmental caging. So we go on with a full stage reinforcement cage, properly lifted and pushed into the fresh concrete. So coming to the concrete, requirement is that, as I said, we need a higher slump flow. Here, generally, we need a higher slump flow, 760 mm around. But as per our Indian standard, we can for underground application, we can minimum requirement is 560 mm, and for our slump flow requirement, so we need to have a higher the cementitious powder. So cement will in the previous cases they have used 350 cement and 350 kg per cubic meter of cement and 250 kg per cubic meter for fly ash to achieve all this strength and slump aspects. So with including admixtures. Coming to the reinforcement cage, this is what suggested in the FHW that we have to have this stiffener bar with a flat kind of arrangement. So we have to round this MS flat and we have to weld it to the bottom and all this along the reinforcement cage and spacer bars. But what it is used in the DFI of India trial also, they have used the MS flat arrangement. But coming to our case, what we felt that this flat arrangement is insufficient for our regular operation because there is a buckling cases are also reported. So we gone with this conventional kind of 16 mm diameter stiffener boss for our pile, but we have reduced the spacing. In conventional cases, BCS cases will be providing 16 mm dia bars, stiffener bars for every 1.5 meter intervals, but here we have use the to 1 meter interval, so it worked well. So accordingly, this suggestion was draft code also. So coming to the launch event, so NRL Technique in front of NRL Technique and EAL, we have done this trial. And show the resonant flow. So while lifting, this auger will help us to remove all these sludges in between, kept in between these augers. Then we lifted the reinforcement cage at a stretch. The bottom will have a kind of conical arrangement for helping us to have easy pushing into the fresh concrete. If needed, we can use this vibrator to push the reinforcement cage further. Generally, with the self-weight and simple manual pushing, it will go up to 15 meters depth. So this is what glimpses of operation. Glimpses of initial pile crisis. So we, as I said, in Indian case, we have a cutoff level which is 2 meters below the ground level. So we have fabricated this kind of site arrangement so that we can push the reinforcement cage 2 meters below the ground level. This is done along with the suggestion what the original equipment manufacturer, they have given the suggestion. It is also suggested in international practices. So we have used this kind of pushing arrangement to push the reinforcement cage 2 meters below the ground level so that we won't make any wastage of reinforcement cage which is kept from that cutoff level to the ground level. So that way we have saved this thing. And this is a typical instrumentation report which was taken from our own rig. So this is what the basic display unit which is held in the hydraulic piling rig that will give you depth, inclination of the mast, everything. So this advanced instrumentation will give you all this concreting and drilling parameters of CFA pile. So this is what the summary of trial piles or initial piles we did at two different structures in NRL. So we have done with the first one with 750 mm dia, three numbers of piles for 15 meters depth. So the soil type is soft to hard clay. N value ranges from 4 to 60, and concrete grade is M30. And workability for slump flow we have maintained 650, and average timing for piling is 33. In case of HU site, 600 mm diameter, 20 meters and 15 meters we done. Here you can see for 20 meters diameter, the soil layer is clay and city sand, and N value ranges from 4 to even to 100 also. And same M30 grade concrete and 40 minutes. So all this 3+1 piles were tested for, validated for safe capacity. This initial load tests were done in compression load 110 tons and lateral load 4 tons and uplift load 45 tons. So coming to comparison between BCAs and CFA, what we done both in NRL. So we have done both BCAs and based on the requirement for CFA. Workability for our conventional case is 180, but here we increased to 650. And boring time, you can see like making the borehole conventional case is minimum 3 hours. It is a minimum 3 hours, and this is maximum 16 minutes. And cage and trimmy operations will trimmy concreting, all these things will around put together around 1 hour maximum. And 11 minutes we can do this retrieval process and concrete filling process simultaneously. And the concreting overall this thing put together will have a minimum of 4 hours, 4.5 hours for our conventional case at particular site for same 600. This is apple to apple comparison for a pile dia of 600 and pile depth of 15 meters and M30 grade concrete. So what you can see, what is the productivity we have achieved? It is more than four times compared to conventional. So based on our experience, what we saw from the this particular implementation phase is that CFA routine piles, so this 1.3 plus working piles, you can see on at the HU location 12 piles and ETP location 131 piles already completed. And this is for a 600 mm diameter and 15 meters length. So soil is silty sand, 30 to 40 minutes per pile, and you can see what is that achieved productivity range. It is you can see 4x times compared to the BCS pile. So you can see after excavating to the cutoff level, you can see how the how well this pile is built up. So can diameter, our requirement is 60 centimeter, sorry, 60 dia, and what we measured is it is slightly 600 instead of 600, it is 610 what we achieved, because there is a soft packet in the soft clay packet is there, so that there is an increase in the diameter of the pile that location. So I think this is what some wrap up outcome of this or advantage of this piling, CFA piling, is that we can end of the pile will give will have a report of how the pile is, how quality we have to give the penetration speed, torque of penetration, torque during the auger penetration, and the rotation RPM. And the first three will give you the concreting speed, retrieval speed and concreting pressure. So as I said, bottom will have high pressure so that the bottom lid will open and concrete will be supplied from the bottom. And the one thing is that the retrieval rate and drilling rate, this rotation, RPM, all these three parameters are controlled, or there is a setting in this machine or control unit that we can fix this penetration rate or retrieval rate or RPM, that we can fix it. So that machine will take care of it. So there is no intervention needed. But this torque measurement will give you some idea about how the subsurface looks like, and this concrete pressure or concrete consumption, that will give you how well the pile is built up. So in this particular case, this is 15.5 meters deep pile, and the cutoff level is around 2.4 meters below the ground level. So we have made like this. and this passes through a stiff clay, and there is a soft clay packet above this one, and density sand, stiff clay, and very stiff to hard clay, dense sand. So this is what the proportion. Then we can see some bulging arrangement in the sandy soil, dense sand layers. As I said, some screwing effect is there in the we will have some good observation about the torque, wherever there is an increase in the torque. See here and here and here, you can see first year we have stiff clay to a dense sand. There is a change from drastic from 13 to 43 n value, and there is a good arrangement of a density sand layer here that is covered here, and one more here. So next one is, so this is what a comparison with our ground case. Second one is rig instrumentation data. Third one is the pit data. So it's the same bulging arrangement is captured in the pit and profile analysis data, and also some increase in impedance in the this stiff hard clay layer, and some as I said, see wherever there is a increase in the torque or torque resistance, there and all we have this kind of increase in impedance. You can see here. So this layer is correspond with this layer is correspond with this one. Here this one is correspond, can see here, and here also can see. So wherever we have this high torque application or higher resistance, so there and all we have observed this kind of increased impedance in the pile, from the profile analysis. So coming to wrap up scenario, so comparing DCS to CFA, productivity is 4 times, and drilling fluid is not at all required, and quality is highly achieved. So we can monitor the pile built up even during the live operation. Concrete consumption earlier, I mean, normal BCS case is 5%, but FSW also allows up to 15%, and this will comes around 10 plus 10%. 10 plus percentages based on the soil condition. As I said, soft clay packets will have more concrete consumption or more diameter buildup. And reinforcement cage, this 3% is considered to have this higher stiffener arrangements. And environmental aspect, so it is of eco-friendly because we are not at all using the bentonite or anything, so that there's no disposal issue or anything. And pile muck, we have to do the controlled disposal. And here, this is not mixed up with any of drilling fluid. So if you have sandy soil layers, so that we can treat or directly use it for any other purpose within the project site. So this is a critical item that how we can control is that first one is drilling parameter. If any obstruction encountered, we have to report it to the supervisor and then extract slightly, and we have to try to re-drill it so that that obstruction or any boulder phase that can care. And concreting part, we have to ensure the workability, proper design should be done, and field trial should be done so that pumpability is achieved. And concrete supply, because it is high productive in nature, so we have to ensure that supply of concrete is timely to the site. And concrete pump repair, to take care of these aspects, we have to have one spare pump for every 2 pumps which is used in the site. And clogging in pipes, if it is achieved, so we have to avoid those things. We have to do the proper cleaning aspect end of every day. We have to do proper cleaning using muds. And concrete interruption, if anything happens during the drilling or retrieval process, we have to re-drill into the existing pile fresh concrete, re-drill into that, and we have to do the fresh concreting, pour the fresh concrete. And in case of cutoff level below the natural ground level, then we have to go for a special pushing reinforcement rebar cage pushing arrangement. And concrete over consumption, that we have to control by proper maintaining RPM and penetration rate. And coming to the reinforcement, we have to ensure that it is stiffened, and if needed, we can go for vibrator to push the reinforcement cage. So this is what my experience with this implementation of CFA pile in India. So I could say I could able to cover whatever I have learned from this initiative, and the floor is open for discussion if any. Thank you for giving me this opportunity. Thank you everyone for patient listening. Thank you.
Very useful and knowledge-provoking lecture, Dr. Sivaraman.
Sir?
Now floor is open for any discussion and questions.
Can I ask one question?
Yes,
Yeah,
sir.
please, sir.
Yes, sir.
So what is the load carrying capacity of difference between conventional pipes and these CFA pipes?
So it differs. Actually, this CFA pile will do better if your pile is designed as frictional pile. The design aspect, as I covered, there if your soil which is surrounding your pile is of stiffer clay kind of thing, you will have better skin friction or shaft resistance. And if it is of medium or stiff clay, you will have equal shaft resistance. But in case of your clay is of very soft in nature, you will have, compared to BCS, your CFA pile will have lesser skin friction value. But end bearing, as I said, end bearing, if your BCS case where there is no, it is not designed as a end bearing pile, then for a friction pile of BCS and friction pile of CFA, your pile capacity will be plus or minus 5 to 10%. On some locations, CFA will give a 5% higher value. In some locations, BCS will have 5% higher than your CFA. So it depends upon the ground soil condition. So even for our for upcoming projects, we are evaluating the CFA feasibility. We find that some locations which are highly favorable for this CFA operation, where our CFA capacity is 5% greater than our conventional BCS case. Only thing is that this comparison can be made only
And what about
to friction pile of BCS and friction pile of CFA.
what's comparison?
Sir? Hello.
Sir, what you have shown in the one table regarding the mixed design, I think the cementitious material is used in a higher percentage than the routine one. So how much it is costly or how it is to be designed? It is designed as a normal design.
One sec, I'll just go to that particular slide. Yeah, it is to be closer to our self-compacting concrete. As I said, we need a slump flow greater than
not
700
this table,
mm.
not this table. It was shown some 1:1.8, some is to something.
Our case, right? L&T Geo case.
Yeah, you show that table.
Yeah, I'll come back to you. So in our case, what I'll just come. Yeah, right here. So in this case, this increase in this powder content can be balanced with increasing the fly ash content. So we can have a balancing proportion of cement, OPC, and your fly ash mixture. So that our intention is to have high slump and achieving the same grade of concrete, or M30 grade of concrete. And one thing I forgot to tell that we have to, sir.
In this design, your cementitious ratio is 1:4.5 in BCIS, and in CFA it is 1:2.8. So 2.8 and 4.5, it's a quite big difference. Almost 60% more.
Yeah, understood. So I admit it. This is what I earlier said, the specific requirement of CFA. In order to make this concrete pumpable or high slump or pumpable, because this concrete should pass through all this length of pile, 2 times length of pile, and from this rig to your pump. So it will comes around 2.5 times the length of pile. This concrete has to flow. So considering that we need to have high slump flow, this is what I can't say this is a disadvantage. This is the specific requirement of CFA.
So what are the actually limitations and disadvantage of CFA?
As I quoted earlier, because this cannot be done for a case where we need to have rock socketing or any grade which is having UCS more than 20, we can't do. And restriction of diameter is up to 1200 diameter. And what I say then, Wherever there is a low groundwater table, so that is not a feasible condition, because your ground soil will absorb the moisture from the concrete. Then your cage pushing will be highly difficult. So as initial slides, I have given the favorable ground conditions. One sec. Yeah, here it is. So your soil should be of cohesive or granular soil with cohesive fractions. Some cohesion elements should be there, and water table should be higher level, and your medium dense to dense sand, silty sand also is applicable, but it should be of well graded sand, not uniformly graded. That is slightly unfavorable, because your borehole will not shape will not be maintained. You will have higher diameter, because screwing effect will attract more soil from the surrounding, and it will make the borehole higher than the required diameter. Then concrete consumption will go up.
What is about the marine clay? Is
Sir?
it? It's a deep marine clay, deep state of marine clay. How it is useful?
Depends upon consistency. So as I said, your concreting area, this diameter will get increases. So that is what the disadvantage, or you can say unfavorable condition. But definitely those clay with stiff, medium, stiff, very stiff, hard, those are all highly flavorable. And soil, clayey sand or well-graded sand, which is within this with groundwater table, that is highly favorable for our case. Mostly in our market, our piling job market, what we are dealing, we will be having this kind of standalone piling job, which are all designed for frictional piles. So easy for us to implement this kind of CFA piles. But only thing is that there is no code, IS code.
In the initial case, your auger tip is closed for that middle stem, no?
Yeah.
How you open it for the concrete?
Yeah, I'll show you one more picture. You can see that bottom we have a hole and we have a cap. I think this is not properly visible. So there is a plastic cap which we can simply punch into this hole.
The plastic cap will fall down.
Yeah. Okay. Yes. Okay. I'll just show you concrete pressure chart.
Right.
So see, bottom initially we will have higher pressure so that the lid opens, plastic lid gets open. Then we can start lifting it.
It does not get damaged during construction? Any possibility of damaging it during?
Which one, sir? Cap.
This cap, there is a plastic cap, no?
Yeah. Like high density plastic polyethylene material.
My one more question is that re-drilling in fresh concrete is done by the same machine?
Yeah, that statement is that if during some operations, for example, lifting operation, 1 cubic meter of concrete is poured, then you find that the next transit mixer is coming late. There is a lack of supply of or late arrival of concrete from to the site. Then there is a gap between your first pour and the second pour, or first TM to second TM. Then what we have to do, it will be difficult because bottommost concrete will get hardened, then your cage pushing will be difficult. In that case, whenever the second TM arrives after late time, we have to drill into the those previously poured concrete. Then we have to start pumping again from the bottom.
But it is with the same
whenever
machine.
We feel this kind of issues.
Re-drilling is done by the same machine.
Same machine.
CFA only.
Without taking out full auger out.
Okay. Thank you.
So for lowering this cage, we have to use some extra steel, because in normal with this resistance against concrete, I don't think for a more length, we have to use some extra steel, say spiral outer ring or something, so that it is strengthened and it is lowered in the concrete.
Okay. So this is what I said. in FHW, what they are suggesting is that to have 6 mm thick MS flat should be made as a ring, and it should be welded to the main bars at every 1.5 meters interval. This is what the suggested practice for CFA in FHWA. What DFA of India did in 2019 is that they have made this same strap arrangement for every 1 meters interval. So what we faced during our trial is that this ring kind of arrangement is not helpful for effective implementation for lifting or pushing into the skate, because that shape of the rebar get sheared. So we made a trial with the same 16 mm dia stiffener bar, but spacing instead of 1.5, we made into 1 meter center to center spacing. So by that way, we have increased that stiffness of the reinforcement cage. And coming to the pushing arrangement, based on our previous, initial trial arrangement and during the working pile arrangement, the cage simply lowering into the fresh concrete, it will go simply by its own weight around 10 to 15 meters. It will just go into the fresh concrete. And after that, 5 to 7 meters manual, those labor can push, or even we can use excavator bucket to push it. If your length of pile is more than 20 or 22 meters, then we can use this. I already shown
Vibration?
This kind of vibrator, cage vibrator.
Yeah.
But self-weight, it will go around 10 to 15 meters by just leaving or lowering their cage. It will simply go into the fresh concrete.
Okay, sir.
Hi,
Thank you.
Sivaraman. This
Yes.
is Jai Kumar. I hope
Yes.
you able to hear us.
Yes,
It
yes,
was fantastic, Sivaraman.
yeah.
And I am privileged to be involved during this, let's say, Rajpura experiment.
Yeah.
At that time, I was with L&T Power,
Okay.
and Dr. KSR was the main implementer who actually tried bringing this CFA file for Rajpura plant.
Yeah.
However, we could not go successful because not for drilling rigs and all, but because we could not produce right grout for it. And entire CFA probably is hinged to the selection and making of a grout, where you can pour it, and then you can pour or you can down the rebar cage. So if you can do that, then this is a fantastic one. And whatever the soft toe conditions or the sharp resistance degradation due to bentonite slurry, let's say, or I would say such kind of a polymer slurries interaction is there, that can be reduced, or I would say avoid or completely removed through this CFA piles.
Yes.
So this is fantastic. We would probably able to see, or we would wish that more and more projects GeoStructure will do with this technology, and win more projects also with this cost-effective technology. So
Yes.
that's all the best to GeoStructure and you as well.
Thank you. Thank you.
Thank you, Shukla sir. And among us, Aniruddhan sir is also with us. So I will request him to please give an expert concluding remark.
Your IVA is here. IVA is joined.
Yeah,
right?
I think he is here. Aniruddhan. Aniruddhan sir. I think he is not connected. So let's, I will hand over it to convener of this SC3, Dr. Jayakumar Shukla. Please conclude session.
Thank you, Dr. AP Singh, for these kind words. And we probably would like to thank Dr. Sivaraman, who has agreed for this special session on this technology implementation through the CFA piles. And SC3 is committed to bring more and more young professionals to speak from this forum and exchange their views and ideas for our own IGS fraternity. So with these words, probably we'll let's say over to Nazim. Nazim can at least have a word for closure of the session. Nazim, over to you.
Aniruddhan sir has joined, sir. He is unmuted. If you want to
Aniruddhan
give
sir.
concluding remarks, then.
Yeah, IVA, concluding remarks from you, CFA pile or CFA technology implementation. So over to you. Maybe I'm not sure whether he will able to speak or will be able to hear. IVA?
He is unmute. He is not speaking.
Anyway, we can close this. That's fine. Yeah.
Okay, so thank you, Dr. Sivaraman, for accepting our invitation and delivering an excellent webinar. And thank you to all the participants for joining this professional webinar. And we'll get back to you all with the second webinar. Soon we'll float the announcement for the second webinar also. Thank you all for joining.
Thank you.